Hi guys, welcome to the lesson of partial differential equations. So in continuation to the topic Cauchy's characteristic method, let's take some more problems on Cauchy's characteristic method. So again, we have a linear partial differential equation of first order, but this time it's non-homogeneous and the condition is given as e to the power x squared. X is from negative to positive infinity, where t is greater than 0 and to infinity. All right, so we have this is negative x squared, in fact, and now we need to solve this problem. And again, we will start with the Lagrange multiplier, so we can write this problem in this manner, that it's dt over 1, that is the coefficient of this component, dou w over dou t, equals dx over 5, that is the coefficient of dou w over dou x, equals the w over e to the power 3t, that is the component of the right side. So we write in the denominator of dw. All right, so now we can simply solve this problem by taking the pairs. Let's take this pair first. So we have dt equals dx over 5. So we can write dx over dt equals 5. This implies that dx equals 5 times dt. And if we integrate this function, we get x equals 5t plus c1, where we can write c1 equals x minus 5t. So we can call it equation number 1, and we will use this later in this problem. So now we can, if you look here, we cannot take this and this pair, because here we have e to the power 3t and it's function of t. But here is dx and here is dw. Therefore, we can just take these two elements, that is dt over 1 and dw over e to the power 3t, so that the equation becomes separable and we can solve it to find w. So dt over 1 equals dw over e to the power 3t, and we can move this e to the power 3t dt equals dw. So we have, now we can integrate, so we have w equals e to the power 3t divided by 3 plus c2, where we know that this c2 is nothing but it's just the function of c1. So we can replace this here, this c2 with the function of c1. So function of c1 is, actually we can see c1 is x minus 5t, so we can write this function of x minus 5t. Then we can apply the initial condition. So the initial condition we have is wx0 equals e to the power negative x squared. So just plug in e to the power negative x squared in place of w, equals e to the power 0 over 3 plus f of x. All right, so we have f of x equals e to the power negative x squared minus 1 over 3. Now, if we have f of x equals this thing, then f of x minus 5t is nothing but just we need to plug in x minus 5t in place of x minus 1 over 3. Okay, so we have the value of f of x minus 5t, so we can just plug in here in this equation to get the desired result. So we have w equals e to the power 3t divided by 3 plus e to the power negative x minus 5t squared minus 1 over 3. So this is the solution to this problem, and we can actually verify whether this solution is good or not. And if we look at the problem and we look at the initial condition and we plug in wx comma 0, so we are uh, going to get this thing that is e to the power negative x squared, because this thing here will be 1/3. So let's try it. Wx comma 0 equals e to the power 0/3 plus e to the power negative x minus 0 squared minus 1/3. This cancels with this and we are left with the power negative x squared. So the condition is satisfied, and we can also check for the equation by simply differentiating first partially with respect to t and then partially with respect to x, and then we can add up with this linear combination 1 times dou w or dou t plus 5 times dou w or dou x, and we will get e to the power 3d. All right, so let's take one more problem. Now if we look at this problem, so we can actually see that if we make the formation of these differential equations, that is the Lagrange form, so we have dx over 3x, because the coefficient of this dou u over dou x is 3x, equals dt over the coefficient is 1 here, and then du over 2t, right? That is this variable here. So now we can solve these pairs. So we have dx over x equals to, we can move this 3 to the right side. So we have ln x equals 3t plus c1, where we can do some more simplification. If we take it this way, that is, this is ln x plus, if we write it ln c1, because it's constant, so we can write anything here like c1 c2 ln c1 e to the power c1 just for our ease. So it will be x c1 with this ln equals 3t, and if we want to get rid of this ln, so we will take the exponential on the base on both sides. So we will get x times c1 equals e to the power 3t, where c1 is going to be e to the power 3t over x. So this is our c1, right? Now we can just check whatever pair we can take here. So we cannot take this pair, this and this, because this is a function of t, and here we have function of x, and the derivatives are dx and du. But if we look at this thing here, dt over 1 and du over 2t, so it's feasible. So dt over 1 equals du over 2t. Again, we can shift this to the right side. So it will be 2t dt equals du. Now the time for integration, so it will be t squared plus c2 equals u, and c2 is nothing but it's a function of c1. So c2 is a function of c1, therefore c2 is going to be the function of e to the power 3t over x. Right, now we can just write u equals t squared plus f of e to the power 3t over x and use the initial condition. So whatever the initial condition we have is ux0 equals ln1 plus x squared. So ux comma 0 equals, this will be 0 plus f of e to the power 0 over x. And then we have this thing is equals to ln 1 plus x squared. Okay, so we can see here that function of 1 over x equals ln 1 plus x squared. Okay, but what we need is function of e to the power 3t over x. So if we want to formulate this thing, now there's a problem here that we have a function of 1 over x, but we need function of x. So what we can do is simply we can flip this x squared to 1 over x squared here, because if we have function of 1 over x is equals to this thing, then f of x is going to be 1 plus 1 over x squared, right? Now we have function of x, but what we need is we need function of e to the power 3t over x. Okay, so uh here we have, okay, one thing we can do here is it will make trouble. Still it will make trouble. Therefore what we can do is we can simply, okay, so now if we need f of e to the power 3t over x, we can simply write 1 plus, we have 1 over x, so instead of 1 over x we can write e to the power 3t over x squared. So now we can get ln 1 plus 1 over e to the power 60 over x squared, where we can move this x squared like this. So we will get 1 plus x squared over e to the power 60, and that is ln 1 plus x squared e to the power negative 60. So finally we have the function of e to the power 3t over x equals to this thing, and also we can now yes, we can substitute this thing here in this equation. Actually we need f of e to the power 3t f of e to the power 3t over x to solve this problem. So let's call it equation A. So plug in the value in equation A. We will get A implies that u equals t squared plus ln 1 plus x squared e to the power negative 60. So in this way we can just solve the problem. All right, so there is one more thing, that in this step we get x in the denominator, but one thing we can do here is that if we just write this thing, this implies that if we write in this manner that x over e to the power 3t equals to 1 over c1, and we can call this thing as simply c because it's a constant, so this will be more easier to work out. So this will be more easier to work out here, because if we have 1 over f of 1 over x, then it will make trouble, right? So because we need here f of e to the power 3t over x and x in the denominator, so it will make trouble in finding out the exact problem. Okay, so now, but in this way we can just solve. Anyways, you can solve this problem as you see that is easier for you. So thanks for watching the lesson. That's all for the time being for now. Hope you guys will understand these kinds of problems. Thank you for watching the lesson. Goodbye.